stirring up the electrons and causing a lot of commotion here, and as it avalanches and it goes through the gaseous tube and the anode picks it up. We'll come back to that after a little while, because Lord Kelvin back in the early 1800s had a gaseous tube that he had some nitrous oxide in gas, and he put like 100 volts on that gaseous tube, and he let it sit for a little bit. Then he took the source off of it and then measured what was in the gaseous tube, and he got over 200,000 volts. So what had happened is that the gas inside there had become so excited that it was producing a lot more electricity than what the input was. And this is Lord Kelvin back around the early 1800s, and he could not explain what had happened, and as usual in the academia, when you can't explain something, you kind of ignore it. You sweep it under the carpet, because it's embarrassing to be the brainy type and not be able to explain something. So a lot of things can't be explained, but what we're doing here can be, and it's very simple, and it does work. And I have about 7 different devices that work totally different, but all of them work on the idea of electron spin, spin one way, spin the other way, and also on electron avalanche, which is what Farnsworth and his multipactors and the clystrons and all that, like in your microwave oven, those things work off it. Now, how do you know all this? You can take a meter that reads the magnetic field, which is the flip side of the electrical thing, and if you have an object that's giving off a very enormous electrical magnetic field, if the electricity part is shielded, the magnetic part is probably coming on through, and you can measure that and you convert that directly into what the flip side was, and you can tell that this resonator thing that you have here is putting out maybe 200,000 volts worth of magnetic flux, and you're only putting like 100 volts into it. So what you do then, you have to have some way of interceding on that magnetic flux, and you build a coil system, and this coil system, each time the magnetic wave flux cuts the coil system, it pumps the electrons that are involved in that coil system, and you're generating electricity at that point. So all of this energy, which like on high voltage power lines that cross the country, if you walk anywhere near one of those, you're inside a tremendous area of magnetic flux. And none of that is being used, it's being wasted. So most of what in the conventional sense in generating electricity or transporting it, most of it just goes off out into electromagnet in the magnetic field, and nothing comes of it. Like when you're running a transformer, the magnetic field around that, or a motor, the magnetic field around that goes out quite some distance, and all you have to do is build a coil system that intercepts that magnetic flux, and you're home free. As many coils as you want to put there, you can multiply it. Each turn will multiply it by that turn. So if you had like 1,000 volts of magnetic flux from this particular device, and one turn of that coil would pick 1,000, and the second turn would get another 1,000, and so on. It becomes it avalanches out so that you end up with a huge amount of energy that you didn't have before. At least you had it, but you couldn't do anything about it. But if you build the coil system properly, you can do a lot about it. Now, back to that gaseous tube that we were talking about a while ago, that relates to laser systems and a lot of things in that particular category. It turns out that there are quite a number of gases that if subject to certain radio frequencies become highly electroactive, much more so than the field which they're being subjected to. And one of those, of course, is carbon dioxide. And when infrared, certain frequency of infrared hits it, it goes completely crazy and you get millions of volts out of it, even though the system that's powering your infrared source might only have maybe 12 volts or less. And you say, well, lots of voltage, no amperage. How you get amperage is when you start earth grounding something. When you have a dead ground, everything will go immediately, or the voltage or potential is what's there. It's the water that's in the lake. And if the dam holds it back, you don't have any amperage showing. But if you poke a hole in the dam, and depending on the size of the hole and the amount that's coming out, that's your amperage. So if someone tells you that in Tesla coils there's no amperage and therefore there's no power and that sort of thing, just tell them to go stick their foot in a bucket and you'll turn your 100,000 volt Tesla coil on and we'll find out. And I don't think they will ever argue with you after that. They probably won't even be around. But some of the devices which we'll be talking about, there's one on the board there now, and this is one of the newer devices. You're looking at one side of it, and the other side is exact duplicate of this side, except there on the other side, which I'll show you in a minute, has a little flea-powered motor on it that rotates a disc which intercepts the block wall in this magnet system. You've got a super magnet, and where the neutral zone is, where the spin is reversed, there's a neutral zone and the magnetic on the magnet. So what you do, you take the super magnet and pull it apart, but it's still interacting so that the composite magnetic field is here, but the block wall is a blank space. And then you take a rotating shield that passes past it, that has openings in it, and each time that opening passes the thing, the composite magnetic field increases considerably. So basically what you're doing, you're interrupting the magnetic field, and at that point you're pumping electrons, and the coils which you see on the outside, inside those white things there with the red wire on it, are super magnets. There's about $800 worth of them in there. So anyhow, it's a pulsating block wall system, and nothing like it has ever shown up in the patent office before. And here in the United States and several other countries I've checked, there's not even a single patent that even has anything that even comes close to it. And that's using all word trains and everything else that could be associated with it. So what you're looking at is a machine which someone may have thought of it, and someone may have built one somewhere, but they sure didn't let the rest of the world know of it. So anyhow, you're looking at the top side, what I call the top side on that particular drawing, and this is the other side with a little flea power motor. That's a little Pittman 12 volt DC motor. It has continually variable speed on it, and the thing here is a dimmer switch off of a General Motors pickup. And it will continuously modulate the power so that you can get any combination of speed on this thing. You can't run that disc very fast because in the magnet system, depending on the percent shielding that you have, and the shielding doesn't work like you think it works. Something that doesn't like a magnetic field will not shield it. So what you have to do is you take a material which knocks the magnetic field out of sync, and it throws the spin throws it at a right angle to it, and when that happens, you're deflecting the magnetic field. For example, if you have a supermagnet here, and it's 100 Gauss on this side and 100 Gauss on this side, and you bring the two close together, you've got 200 Gauss. So what happens when you start interfering with this composite magnetic field, you can knock it down by, say, 10% up to about 90%. 1 Gauss is equal, based on the original definition of Gauss himself, is equivalent to 100,000 volts RMS. So you can see that if you're knocking 10% off of that composite thing there, well, that's 10% of 200, and 200 times 100,000 volts is how many volts? That's how many volts potential you could get out of this thing if it's running out of each one of those, if they're running at full force, which you obviously cannot do because the wire there limits it to about 1,000 volts and about 50 amps. So the system you're looking at with 12 volts in will put out 8,000 volts fairly easily at 50 amps. And the amperage is real low on that motor. It's a flea power motor. It's down into the milliwatts. So you can see immediately it doesn't take hardly anyone or any instruments at all to verify this thing, because it becomes immediately obvious you're getting so much more out than you put in that if someone wants to debate it, they're going to look silly. And the other devices I have, we're going to have to work off of smaller photographs, but I'll tell you about one of them. We were talking about exciting gases, and the one that I was telling you about on the carbon dioxide thing, I've actually built, and the output on it, I have a little neon tube that I built out of clear plastic tubing like you use on water, on your refrigerator or something like that, except it's about as big around as my finger. And I fill that tubing. I've got a way to fill it with the particular gas that generates the frequency which I need to excite the carbon dioxide. So I'm using a very small voltage, a little neon tube 12 volt transformer that puts out about 3,000 volts or so, and I'm using that on this tubing. It's just like a neon tube, except that it curls very nicely around the clear lucite tubing that's got the carbon dioxide in it. And the cylinder is set up, it works on about the same type of thing that lasers work on. So I make a diode, a glass tube type diode, by putting a certain kind of metal on one end and a certain kind on the other end, so that there's electrical difference in the activity of the two metals, so that I can have on my out, I can have a supposedly plus and minus. Actually, anytime you're in electricity, it's all more negative or less negative. There's no such thing as plus. That's something that Benjamin Franklin used, and he used it correctly, but everybody since him has used it wrong. When you come to plus electricity, the only time you're going to find that's when you're working with atoms and molecules and various sorts of things, where the rings of the particular atoms have missing electrons in them, where these things are going to be pulling at each other. And of course the core of the atom has what is supposed to be a positive charge. So everything that you're going to be looking at in this sort of device is going to be either more negative or less negative. And they're all going to be built around the idea of electron spin. One way it's spinning, well, you've got a magnetic field, and when it comes the other way, you've got electrical field. And it's just pulsing like this all the time. And that's why I can take that block wall area of the composite magnetic field and build a pulsing block wall magnetic electrical power generator. And this thing, if you made it like 20 feet tall or more, and each one of those cylinders there was like a small barrel, you would be getting a megawatt out of each one of them. So this device, about as tall as this ceiling here, scaled up to that size, would be putting out 8 megawatts. And it could go a lot more than that if the system could handle it. The speed that you're running that shield at will determine the output. And you can run it at any speed you want to. So you can actually turn this thing up into a ball of fire if you're not careful. Okay, we got some more photographs. Okay, this is the thing sitting on one side. It's made so that it sits either vertical or on with the motor thing under it where you don't see it. Okay, this is what it looked like in the building stage. Those things are just sitting on there. They're not bolted on just yet. This is what the magnetic shield looks like, but the magnetic shield on the loose side that it's cut out of, it's a perfect circle, and it's 13.5 inches round, and it was done by a it's a router, computerized router table, and you can put anything you want in there and it will cut out the perfect picture of it exactly the way you want it. So anyhow, it cut the hole out in the middle where the spindle comes through it, and there was paper over this thing originally, and where you see the blue there, I left the paper on it while I was putting the metal material on the surface, and then after I got it on there and got it dried, then I peeled that metal thing off in the middle. Of course, it was kind of messy looking, and on the underside where you don't see, there was another sheet of paper where I actually drew the holes that would be drilled out and all the other stuff. So I just simply flipped it over and used a drill press and drilled out the little holes that let the magnetic field hook up to itself. And that's what we have there. Now, in doing this sort of thing, okay, well, I'll tell you what it is, and then y'all can find it for yourself. Edmund Scientific and the Exploratorium out in San Francisco had Westinghouse put together a chart showing all of the different frequencies as relates to the electromagnetic field, and it explains what they are and what they do, and it's a very useful device in being able to design your coil systems and a lot of other things, because it'll give you some ideas to what frequencies you want to target in order to achieve a certain level. For example, over on the low end there, it's down around in 2, 3, 4, 5 cycles, and it comes up into the like the sound region where you hear, and then it goes from that into the, at about 20,000 cycles, it's moved out of that particular frequency range into radio frequency range, and from there on up, you're in radio frequency. You get into the normal radio frequencies, then you get into the higher frequencies, you get into the megawatts, then the gigawatts, and on to wherever else. And the faster these things are cycled, the greater the electrical energy output as far as a magnetic field is concerned. And if you intercept that magnetic field with a coil system, you're collecting the energy from that magnetic field. So just about any and everything that has a movement of electrons in regard to cycling at various frequencies will give you a lot of energy. This amount of electrons at a low frequency won't give you a whole bunch, but when you get up to the megawatts, you got this much. When you go into the gigawatts, it goes out of the ceiling. And the same amount of electrons, and they're not being damaged in any way, they're just simply being flipped. And they'll be there. They were there at the beginning of time, and they'll be there at the end of time. So it's a form of energy which is doesn't interfere with the environment in any way. It does not react in any other way that's unfavorable. It's continuous and it's everywhere. It's a source of energy which is basically, as humans are concerned, forever, and it's non-depletable. And the electrons that are giving off this electro field and magnetic field just simply flip to whichever position they're going to stay in for a while, then they flip back to the other position. So they'll always be there for you. And this always kind of upset me a little bit, because the people that are working in atomic energy, in order to get at the energy, they have to tear up the atoms and do all kinds of other things which my personal opinion is they're stupid. Trying to get energy out of something that you have to spend billions of dollars in order to get it, and when you got it, you got all kinds of other problems, and you've got a steam engine that runs for you and generates your electricity. So in this particular system we're talking about here, in mass production, the cost is very minimal, and the life expectancy of the device, as I build them, would be basically, it would exceed several generations of people, and maybe a lot more than that, the same device, because redundancy is built into them, so that actually what I say they will do, they will probably do maybe 8 or 10 times what I say they do. And in marketing something like this, you can't really tell people what they're getting. So basically what you tell them is it's an auxiliary backup power unit for the power unit they have, and they will soon figure out, they will notice almost immediately that there's something there which they had not expected, and if they start pushing it a little bit, they'll find that they can push it a long way without getting in trouble. So these things, as far as peer review goes, I'm essentially immune to peer review, because I'm independent and I don't need anyone else's opinion. So I simply go and do it, and let the people that are thinking that they don't like what I'm doing, that's their problem. So if they want to bite themselves like a snake, well, they can just have at it. But my approach is very honest and straightforward, and if anyone wants to take it on, well, they'll end up looking like a fool, and I will just simply step back, and I won't say anything and just let them have at it. But generally speaking, it's not open to discussion other than whenever I want to talk about it, because there's just too many people and too much going on, and I really don't have time to stop and explain the thing all over. So basically what I do, if someone calls me and says that they would like to manufacture this particular system, I have plane loads of people coming in from Japan on this sort of thing almost every time I give a speech. And I've been there, and I have people from Europe and all over, and outside the United States, they don't have this hang-up about getting something back which they think that was never there. If the electrons were never there, you wouldn't get anything back, I can assure you. So you're not getting something back for nothing. You're just simply playing with the system as you would with a lever or a pulley or something like that, and you're causing the electrons to avalanche or whatever action you're getting out of them, and that gives you your higher rate of energy out. And there's nothing unusual about that. As a matter of fact, in chemistry, the term free energy is used. You have basically, when you make a chemical action, you will get basically just a mixture of things and nothing going on, or you'll get probably an endothermic action where heat is absorbed, and then you have the exothermic version of it, which means that if you put two things together and these two things equal this, and like a explosive, anything that's explosive or like an atomic bomb or something like that, the amount of energy required to get all of that energy out is not anywhere near the amount out. An atomic bomb, I've worked with them, and worked with the people out in Nevada on the atomic bombs some years ago, and I can tell you what they look like, and they're nothing at all what everyone thinks they look like. The ones which they were using to blast out these enormous craters that were several thousand feet across and maybe 1,500 feet to 2,000 feet deep. Basically what happens is when the explosion goes off, it pushes the surface up like so, and in the process it powders it so that whenever the explosion starts going back into its normal thing, well, the dirt craters down into it. But something that will do an explosion like what we're talking about there is a piece of steel pipe about 10 feet long, about this big around, and it's loaded with the atomic material, and they bring it over with the DC-3, at least they used to, and load it onto the back of a pickup truck, and the people that are doing it have no shielding or anything, and they take it to the well and they lower it down into the hole that they've made, and then when they do that, they fill it up with this pretty white sand like you find in the cigarette disposal things in some office buildings. So anyhow, what happens is you have an avalanche effect there where you have your main explosive, and then you have maybe several stages like where you'd fire a bullet into something that was unstable, and then it would start exploding, and that in turn would explode something else, which when you get to the main atomic material, well, that's where your main explosion comes in. So there's sometimes one or more stages of walking into the big explosion. So the amount of energy that it takes to set that thing off is maybe 10 or 12 volts or something like that to trigger that action, and you can see that an atomic bomb, when it goes off, there's a lot more than 12 volts worth of energy there. So in chemistry, this is called free energy, and the term is used without any reservations. It's not considered to be vulgar or stupid or anything like that. And if you take any university chemistry book and you look in the back of it and look for free energy, they'll have quite a bit on it. And I've got some information on it which I'll show you. Okay, this is the from the university textbooks. It's the little microphone when the broadcast part of this thing. If I get my arm up against it, well, it does that. So, and there's one in my pocket too. I've got one here and one here, so I can't put my hands anywhere. But anyhow, this is the summation of what free energy is, and in relation to physics and chemistry, and best explained there that in the sense of charged particles, which electrons are, and in sense of other types of energy, the charged particles, if avalanched, will give you this tremendous increase over what you had to start with. So in chemistry, that's real nice, but in physics, where it overlaps into physics, you start getting a lot of people that are giving you a bad time. Now, basically there's a statement on the bottom of that I want to read to you. Okay, the statement being that, well, one of the statements is faster the cycling of electrons, the more energy present, energy greater than ambient based on established definitions from the gas laws refer to this as free energy. And the required formulary on that would be, if you want to put it in a context of what you're expecting to be seeing, A would be ambient or background, and ambient may be a huge amount of potential. For example, the Earth, whenever you calculate it out properly, everyone will tell you that the Earth has very low, if any, electric field or magnetic field. And there's a reason for that. The people that measure it take their instruments and they measure from here to here when the whole area that they're in is the same ambient level, so they don't get much of a change. But if you measure correctly, one way to do that is to use, instead of a contact instruments, is use electrostatic voltmeter. And you will find out real quick like that the Earth's potential is many, many times anything that you would have ever imagined. And you can also use magnetic measuring things. For example, if you get and flying an airplane with a magnetic measuring instrument at 1,000 feet above the surface of the Earth, and you're reading 1,900 gammas. So you're 1,000 feet away from where the source is, and so you have to take 1,000 times 1,000 is the normal way to do it, but in a three-dimensional sense you have to cube it. So, but we'll just take the square thing, and that's 1,000,000 times 1,900 gamma. That would be 1,900,000 gammas. Is that correct? Okay, 1 gamma is the electromagnetic equivalent of 100 volts RMS. So in flipping the coin, the magnetic equivalent at 1,000 feet, reading at 1,900 gammas. The gamma here is not the impact use of gamma, which everyone thinks it is. Gamma is a unit of magnetic flux in this case, and it was a long time before the people knew that there was such thing as impact energy or high impact type things coming in, like gamma rays, say, from the sun. So back in the 1920s, the proper types of magnetometers were being built. They started building them at that time, and they were able to measure the Earth's magnetic background in various places. And it's considerably more than anyone would ever imagine. If you take this thing through several stages, and based on what you could read from your instruments and other things, and then you feed in the speed, the speed at what mass is moving at, times the mass is the energy. So if you take the Earth at the speed it's moving at around the sun, and the whole solar system is moving through space, and follow it through all of the stages and feed it back into it, the actual amount of voltage, which that unit that we talked about a while ago that sounded so big, actually comes out as something like 190 trillion volts where you're sitting. And the reason you don't know that is because it's ambient, it's the background voltage. And what happens is when you have turbulence, like in weather systems and other sorts of things, or like the wind is blowing quite strong, you're disturbing electrons, and when you do that, well, you have something other than ambient. And when you have other than ambient, it's going to unload itself and try to get back to ambient, whether it's over or under ambient. So any kind of electrical generation system is going to be playing with the background voltage and variations from it. So any way that you can get a variation from the background, anything between that variation and the background is useful energy. And there are many, many ways to do that. In one of my books, I tell how to use a plasma globe, and the magnetic field around that plasma globe there is about 400 milligauss. Milligauss is equal to about 100 volts. It's equal to a gamma, or a equal to 100 volts. Milligauss is equal to 100 volts RMS of magnetic flux. So there's about 400 milligauss that you read on your magnetic reading device for the magnetic field. So that means that you've got equivalent to 100 times 400, that'd be 40,000 volts if I'm correct, of magnetic flux there. So that means that each turn on that coil that's wound on that piece of PVC that's sitting on the top there, each turn will pick up 40,000 volts of magnetic flux. So if you have 10 turns, you've got 10 times the 40,000, or you can put any number of turns you want on there, and then on the downside here you tune the coil with capacitors or resistors or various other ways of tuning between the two leads that come off of there, so that it works at the frequency that the plasma globe is working at. So in this case you've got like 125 volts in, but you can take that 125 volt unit out of there and use the little 12 volt neon tube transformer and replace it, and that same plasma globe will do everything that it does with 120 volts. So you can take 12 volts in and you can get say 400,000 volts out. And the voltage, again, people will say lots of potential but no amperage. That's what everyone likes to say about this type of system. But I would like to remind you, if you're standing with your foot in a bucket of water, don't touch. Because a dead short, you get all of the potential flowing at one time. So once you've got this much water behind a dam, and you have some way to get it out, the rate that you're getting it out would be your amperage. So potential is exactly what it says it is. It's not something that's useless or somebody dreamed up, or it's something that can't be made into useful energy. If you've got potential, it's potential regardless of what anyone might tell you. So you can see on this particular device that it's very easy to get out amounts of electricity that are larger than the amounts that are put in. It's using an avalanche effect and electron spin.
Run that off the 12 volt battery with the transformer?
Okay, whenever we get to a certain point here, ready for questions, if someone will please let me know, we'll get to you then. Okay. Okay, why bother with this sort of thing? Why bother with it? Okay, back in biblical times, we have a piece of rosin with a bubble in it that National Geographic analyzed the oxygen-nitrogen ratio. So back in biblical times, the oxygen ratio was greater than 30%. It was approximately 40%. By year 1900, we have of record through government information, the oxygen level was 30, I believe it was 35%. It says on here. But anyhow, by 1984 and The Blue Planet by Carl Sagan, it had dropped to 18%, the ratio of oxygen to nitrogen. And today, the best case you'll find anywhere in the world is most likely going to be 15%. There's a few places where it's a little bit more, but if you go to the large cities like Jakarta, Mexico City, and Tokyo, and the ones that are over 20 million, some of them go well over 20 million people, the oxygen ratio there is 7%. And they have little machines on the street where you can go up and put your nickel in and breathe some oxygen. And what happens when the oxygen level drops below 15%, all of your disease mechanisms, your germs, your viruses, and everything else, this includes all of them, no exception, are anaerobic, which means that they thrive in an oxygen deficient atmosphere. So if an individual in their state of health, if due to their blood or circulation problems, various other problems, if the oxygen is not getting to the right parts of the body, things like cancer start kicking in and all other kinds of illnesses. And about the only way you can correct those is by correcting the oxygen level. And there's some simple ways to do that. Hydrogen peroxide, like you use to wash your mouth out with, is oxygen and water in combination. It's got an extra oxygen, and if you put it in a glass of water and drink some of it, you don't want to get it too strong, but maybe on the 3%, you might put a couple of spoonfuls in a glass about like so and drink it, and it immediately charges your system up. It's just like you'd put a new battery in an automobile that was just about to flip out. And in doing that, I know of some very interesting cases where this has been tested. And if you got someone that is terminal and a doctor sent them home to die, and you do this sort of thing on them, and a week or two later they're up running around as though nothing had ever happened, and they go to get their test at the doctor's office, all their blood tests ran and everything, and all the enzymes and everything indicate the cancer is no longer there. And I have personal knowledge of people that have had cancer of the pancreas and the liver and other things. I also have personal knowledge of a dog. One of my neighbors had a dog that had developed a horrible cancer on one of its legs, and we started putting the hydrogen peroxide into the drinking water, and about a month later we took photographs when it was in a horrible shape, and about a month later we took photographs, and you could hardly tell that anything had ever happened there. It had healed over and that sort of thing. So these oxygen therapies that the hospitals like to work with, where they like to put you into a hyperbaric chamber in order to heal or something like that, they're actually doing what you're doing with a hydrogen peroxide, but they're doing it in a way which it costs a lot more money. And of course they're not about to tell you about hydrogen peroxide. So I'm not the only one that knows about this. There are any number of books that are written on it, and it's quite well recognized in the alternate therapies. For example, on your computer, if you plug in the words alternate therapies or hydrogen peroxide or any number of other things, you will, like on Alta Vista, you pull up almost 7,000 articles that have been published in relation to, say, hydrogen peroxide therapies. And a lot of them are published by medical doctors and people that are working inside the hospitals and that sort of thing. And I'm suspecting that a lot of times when all of this expensive stuff they're giving you, they know it's not really going to work, and it's probably more likely to kill you than cure you. Most of the medical procedures are keyed to treat the visible symptoms and not the actual cause. So they make you feel better, but they don't do much for getting rid of what you need to get rid of. Okay, well, we're kind of off on a tangent there, but These electrical systems that we're talking about here do not interfere with the oxygen supply in any way. There's no way that they interfere with the oxygen supply. Now, a gallon of gasoline, when you combust it in an automobile, uses 200 pounds of oxygen, and there are 4 million barrels of gasoline each day used, and so you have to multiply 44 gallons by a barrel by 4 million by 200 pounds, and you can see how many pounds of oxygen is taken out each day. Okay, I'm told that we're ready for questions, and I'll take a few here, and then we'll see what to do next. Okay.
You mentioned in this CO2 device that you built that you had a gas that you put inside the...
I can hardly hear you.
In the CO2 device that you made,
Uh-huh.
you had a gas that you used to run that with?
Yeah, I used a little piece of dry ice. I dropped it in the cylinder and closed it on each end and sealed it with plastic material, and it became my carbon dioxide source.
Did you had another gas that you used in combination with that?
Well, you dope it with another gas, which I'm not going to tell you about, which amplifies the system by a few thousand times. It makes it's very active to begin with. It'll put out on its own. I think we have reached the end here, and let me tell you this, there is a huge amount more to be talked about, and I've got a lot more information with me, and at the workshop, which is Monday at 1 o'clock, you'll be, if you come, you'll be getting a lot more information, and we'll get to your questions then.
Are you going to
Okay, thank you.
your devices?
Hey, you do such a great job. Nobody wants you to get off.